All right, guys. So let's look at problems 1 through 8 first. Are there any questions on problems 1 through 8? Let's just pick one out at random. Let's say 2. So A11 would be what? -6. I'm drawing circles. So it would be a circle, it would be -6 because we're looking at first row, first column, which would be -6. Let's say 8, D42, 9. Fourth row, second column would be our 9. And that's it, because it's row and then column. And really all of those should be lowercase, not uppercase, but I'll fix that later. Okay. Let's look at 9 through 12. Well, we can just go on and state the dimensions of each one. The dimensions of A are 4 by 2. The next one would be 1 by 4, because B is 1 row, 4 columns. Rows and then columns. D is 4 by 4. And C is 3 by 5. 3 and then 5. Any questions on elements or dimensions? I'm going to keep doing that. Questions on 13, 14, 15, or 16? One of those that y'all want to look at. Yeah, we can plug all these into the calculator. So if we look at 13, we can define this as A times B. So when we pull up the graphing calculator, we can go second matrix over to edit and edit matrix A. Now the first matrix we have is A 2 by 3. So we have this matrix here. And we can enter it in 6, -7, 4, 2, 8, and 0. So that would be matrix A. Now we need to edit matrix B, so we can go second matrix over to edit and down to matrix B. And matrix B is a 3 by 1. Then we would have 9, 1, and 0. And yes, I did type in 0, 1, but that's going to be the same as 1. Mistakenly typed 0 first. Any questions on how we entered the two matrices in? Now we can go second quit. Now we'll recall second matrix A, and then we have second matrix B. Since they're multiplied together, we don't have to put the sign there. We can just do A, matrix A times matrix B. And if we hit enter, we get 4726. Questions on this here? And we know that this works because this is A2 by 3 being multiplied by A3 by 1. So the 3 and 3 tells us that it works. Now the 2 and 1 is our new dimension. So the new dimension should be A2 by 1. This is a 2 by 1. No, but I mean, this is telling us that how it works. Because if it does ask to determine if the following two matrices can be multiplied, that's how we can do it. Any other questions on 13? Any questions on 14, 15, or 16, or one of those that y'all want to look at? No? Do we want to look at 14? Okay. Now we can do this by hand, and if we did it by hand, what we'd be doing is we'd multiply every element inside the matrix by 1/2 and multiply it by -3. And then we would add the matrices together. Now we could do this in the calculator as well, because if we did this in the calculator, the first thing we'll need to do is input the matrices in. So the first matrix that we have is a 3 by 2. Well, try this again. Okay. Three by 2. And it'd be 8, -4, 10, -20, 4, and 16. Because that would be the first matrix that we have, yes? Now we need to put the other matrix in, so we can go second matrix, go over to edit and down to matrix B. Now matrix B is a 3 by 2 as well, because for us to be able to add or subtract two matrices, the dimensions have to be the exact same. So this one here, where you'd have -1. Well, our next number is 1/3, so we can go alpha y equals enter 1/3. Our next number is 0, 2, 2, and 4. So we define those two matrices as A and B. Now once we have them typed in, we can go second quit. Now what do we have? 1/2 times matrix A, yes? So we'll type in 1/2. So 1 alpha y equals enter over 2, or we could do alpha y equals enter to get the half and then do 1/2. Because we have the 1/2, yes? And it's being multiplied by which matrix? A, so we can go second matrix A. And then what do we have? -3 times second matrix B. So the answer is 7, -3, 5, -16, -4, and -4. Any other questions on 14? Questions on 15? So 15 we can plug into the calculator later as just, we define this as matrix A, and we would type it in as 14A, and the calculator will give us the answer, because we're just multiplying the matrix by 14. Or we could just multiply each element inside the matrix by 14. Either one would get us to the correct answer. Any other questions on this here? Questions on 16? This is not possible. The calculator, if you type this in and hit enter and plugged it in correctly, it will tell you that there is invalid dimensions, because for us to be able to add or subtract two matrices, the dimensions have to be the exact same. Here we have a 3 by 3, and here we have a 3 by 4. The two sets of dimensions are not the exact same, so we're not able to add or subtract the dimensions from each other. Any other questions on these here? Any questions on 17, 18, 19, or 20? Questions on 17 through 20. So we're good with addition, subtraction, and multiplication?
I actually have a question. I thought you said that that would still work since you could do 3 by 3. But it's on 16.
That is multiplication.
Okay.
Yeah, since this is subtraction, it wouldn't work. Now, if we were multiplying them, this would work, and we would get a 3 by 4 as our new matrix. But because it's subtraction, it doesn't work. For like this here, these are being multiplied, and we have a 1 by 4 being multiplied with a 4 by 1. The columns of the first matches the rows of the second, so this does work. And our new dimensions would be the other two. It should be a 1 by 1. And this would be 352. There's an awkward space on the answer key, but it is one number, 352. Any other questions on these here? And number 19 does not work. Questions on 21 through 25. One of those in particular that y'all want to look at. Huh? 21. If two matrices are inverse of each other, how can we test it? How can we know it? Because A times B should give us what? One, zero, zero, 1. And what did we call this matrix? The identity. Because if two matrices multiply together and give me the identity, then they are inverses of each other, yes? So what are we needing to do? We need to multiply the two matrices together. Exactly, we can do what? We can plug them in the calculator, because multiplication we can still do in the calculator. Now I'll go on and do this one by hand. 7402 times. And if we get the identity matrix, then they are inverses. Now if we did this by hand, we would go over and down. Now our first number would be 7 times 1/7, which is 1. 4 times 0 is, so we have 1 plus 0. Highlighter. Well, we can do it again. We would go over and down. 7 times negative 2/7 is negative 2, because the 7 in the numerator would simplify with the 7 in the denominator, leaving us with negative 2. 4 times 1/2 is going to be plus 2. In the denominator, well, the bottom row will go over and down. Well, 0 times 1/7 is 0. 2 times 0 is plus 0. It's looking good. Then the last one will have 0 times negative 2/7, which is 0. 2 times 1/2 is plus 1. What do we get? We get the identity, yes? So are these two inverses? Yes. And that's it. Questions on this here? Any other questions on inverses? Now, as looking at this yesterday, this here should be yes, that these two here for 23 are inverses. 23, they are inverses. But 24, this is no. 24, they would not be inverses. If we do the multiplication, it doesn't work out right. But let's go on and actually find the inverse of matrix A for this one, because we'll need to look at those also. Now to find the inverse, it's 1 over AD minus BC times the matrix D, negative B, negative C, A is the formula. Now for us here, this here would be 1 over 18 times 15 minus 27 times negative 10. Inside the matrix, A and D would flip places, so 15 and 18. 27 would become negative, and negative 10 would become positive. Now here we would just need to simplify the denominator. Well, negative 27 times negative 10 is negative 270. 15 times 18, 0, 90, and then, so 270. Huh? Negative 10. Now here the negative and negative would make a positive, so we get 1 over 540 times 15, negative 27, 10, and 18. Now the last thing we need to do is multiply through here. So 15 over 140, or 540, is 3 over 120, which would reduce to 1 over 40. Negative 27 over 540. Well, they both have 3, which would be negative 9 over 180, which would be negative 1 over 30, and this would be 1 over 54. And the last one is going to be, because 18 over 540, well, 9 can go into 540, which would be 60, which is 130. Not 130. Huh? Okay. We can do it later. Thank you. Thank you. Because here, because 3, 1, 24, because, well, the issue isn't so much as this being 130, it's the fact that these are both the same. Because up here, negative 27 and 18 aren't the same. There's no way they can reduce to the same number. So if we look back at negative 27 over 540, well, 9 will go into both, which would be negative 3 over 60. That's it. So that should be negative 1/20th. Is that the same as what matrix B is? Because I can erase this here and rewrite what matrix B is. Because matrix B is 1/36, negative 1/20th, negative 1/54th, and 1/30. Well, those aren't the same thing, are they? No. We didn't. I just wanted to go over how to do an inverse by hand. And also it shows us that these aren't inverses, because the correct inverse for this here is 1/40th, negative 1/20th, 1/54th, and 1/30th. Yeah, no, actually this should be, I simplified that wrong. I was going too fast. It should be 1/36. It's still negative, because that shouldn't be negative. It should be positive. So that's still right. This here, they're not. And if we plugged them into the calculator and did A times B, we would not get, and I think some of you who plugged it in did not get the identity. No. You'd get something probably close to it, but it's not exactly this here. Any questions on this here? Okay. Now 26 is asking us to find the inverse. It's 26 through 29. Is one of those in particular that y'all want to look at for finding the inverse? All right, we'll just look at 26. Now we can do this in the calculator. So we can go second matrix over to edit and put the matrix in. Now for us here, it is a 2 by 2. And it would be 8, 27, 2, and 0. 8, 27, 2, and 0. I can quit. Now they call it the matrix. We're going to go second matrix A to the negative 1. Because that there is telling us that we want to find the inverse. And we get this here, 0.5, and then these two other decimals. Now how can I convert it to a fraction? Math, enter, enter. So the correct inverse, or the inverse for this here, is 0, 1/2 in the top row, and in the bottom row from left to right, it's 1/27 and negative 4/27. And that would be the answer. Any other questions on the inverses? Now we do know a matrix does not have an inverse if the determinant has what value? Y'all remember? The determinant can't be what? Take a guess. 0. It can't be 0 because in our formula it's 1 over AD minus BC times D negative B negative C and A. Because this here is the determinant. We can't have it be 0. We can't divide by 0. So if we looked at this here, well, the determinant would be 9 times 40 minus 18 times negative 20. Because if this is 0, then it doesn't work. Here, it won't be. And this here, especially, I'll point this again when we look at determinants, because that's the last thing we have to cover. Be careful with your signs if you're doing this by hand. Because there are several of you who, on the homework, lost a few points. Because from here to the next step, you went on and changed the signs, even though it didn't need to be changed. Here, it is going to change. Because these two numbers here, when I multiply them together, are going to be what? Negative. Because when we subtract a negative, the sign will change from negative to positive. So here, just checking to see if it does have an inverse, 90 times 40 is going to be 360 minus. This here is going to be negative because 18 times negative 20 would be negative, and this is the negative and negative would make a positive 720. So this would have an inverse. Now, if this 20 had been positive, then it wouldn't. Any questions on this here? So 20 or 30, 31, or 32, which one of those three determinants do we want to look at first? For fractions? Because we want fraction, yes, so it is right there. So we can hit 1 or enter, and it'll pull up fractions. Come on. There we go. And then it'll convert it to a fraction. If not, I'll just look at 30 for the determinant. Now, there's two reasons we know we're taking the determinant. One is because we don't have actual brackets. It looks like absolute value bars for a matrix. Secondly, well, at the top of the page for problems 30 through 35, find the determinant of each matrix. For a 2 by 2, we're doing the cross method. I think Kansas calls it the butterfly method. Here. So going from left to right, we're going to do negative 7 times 8 minus 14 times 21. And we can calculate that out. Now, this here on some of the assignments for a problem like this here, you changed it from subtraction to addition. We can't because 14 times 21 is going to be a positive number. Now, negative 7 times 8 is going to be negative 56 minus 14 times 21 is going to be 294. And when we subtract these here, we get negative 350. It's really according to the properties of the determinants. Is the reason we're subtracting. It's going to be from the left to the right. And I think that's also going into a little above what we would do in here, because I can't remember the correct terminology for it. It would be our row, something with the rows and columns. The fact that the numbers, we would pick one of them here and 21, and then take ij for negatives and positives, dealing with it times the other one, dealing with actual powers and exponents. And then when we do the second one with the 8, it would actually work out that the powers for it for negative 1 would end up being, if I'm remembering the formula right, and this is just off the top of my head, plus j times kind of the determinant of the other, and that might be something completely different. But it's something along those lines. It's a little weird, and it's more calculus based than anything else. I'll have to look it up.
But if you're working that problem, how did you know to subtract?
That's because for the determinant of this here, for any matrix A and B, A, B, C, D, it's always going to be A, D minus.
Okay, so that's just the formula.
By the formula, it's minus.
Okay.
Yeah, and the reason I was pointing out the addition subtraction is if the value of BC itself is negative, then we'd add. So any other questions on the 2 by 2?
Sorry, guys.
Nah. It probably helped some of them out. Yep. Now the 2 by 2 works pretty well with the formula. Now the 3 by 3 is a little more difficult because what we're going to have to do is take the diagonals, which would be all of these here, the 19, negative 2, and 15, negative 6, 0, and 3, and multiply each one of those groups together and add those up. And that would give us our first number. Then we would do it going the other direction, multiply all those groups together and add it up, and subtract those two numbers from each other. But guys, what's an easier way to do it? Calculator. The graphing calculator, because what we can do in here is we can go second matrix over to edit. This here will be a 3 by 3. And we can plug the numbers in. So we're looking at 33. So it'd be 8, 19, 3. And then we would have -6, 4, -2. Well, that shouldn't be 0. That should be 15. Then we should have 0, and then -1. At this point here, we can go second quit. Then what we would do, second matrix. So we need to go over to math, and the first one in the column is DET, which would be determinant. Second matrix A, enter, and the correct answer would be -896.
I think it's easier.
Yeah.
To just work it out after.
Yeah. Yeah, this one here is actually not that bad.
Are there problems like this on the ACT?
I think so, because some will ask for the determinant. Yep. Yeah, number 35 would be a little challenging to do by hand. Yeah. Yeah. Yeah, so this one here, I already lost the number, is -896. Yeah, so Ms. Ferris, if we were doing this by hand, we would take this. Yeah, it would just take a while is the only drawback to it. And then the sum of those, luckily this is not one of the academic questions because this would take way more than, yes. Luckily that's 0, 0, -32, -30, so we'd have 0, 2, 7 carry the 2, 570, oh, that's nice, -602. Here, 4, carry the 5, 114, oh, 18 and 12, carry the 1, 216, 0, 330 subtract, and if I did this right, I don't think I did. Yeah. That's what I get when I rush. 4 carry the 5, yes. 12, 18, 6, yeah. There's some error somewhere in there. But that's it. Any questions on anything else on this here? We good with this here? All right, so because it is Thanksgiving, the week before Thanksgiving break, all the assignments are due Thursday before the end of the day. Okay?